So thank you first for the opportunity. So I would like to introduce myself. So I'm Alberto Barroso. I'm head of decision science for Tetra Pak. Have been working in Tetra Pak now 2 years, and I'm based in Sweden basically, and more specifically in Lund. So our data science center of excellence is basically connected to the business transformation office for Tetra Pak under the CFO. And I would like to share with you just a couple of insights of what we have been doing, what has been our journey basically, and what has been some of the lessons learned of this journey, together with some use cases. If we have more time, I have a couple of them. So the first thing, just to reflect and to be a little bit humble to start with is we are not typically as humans taking decisions based on data. So we are very emotionally driven. This is something that cognitive science, the last 20 years have been, validating. So that's an element that we need to reflect on. So even if we have facts and we have proven science, the application of this science has to do with the emotional connection. So that's an element that we need to realize. We are typically biased. There are, hundreds of different bias validated, from anchoring effect to, negative bias, positive bias, all of them, they are basically taking part of our decision making. So what we try to do basically in decision science is, try to understand how to improve this decision making. And of course, it's about understanding facts through statistics, but it's also about understanding our cognitive bias as humans. If there is a human that is taking decisions, that is typically the case. Now, decision science for us is the process of monetizing this data. So we have a structured process, and it's turning information into better actions at any scale. And the element of at any scale, I think you have tackled, Jan, is basically about automation. But we have basically decisions that are very unique, and they are not very frequent. But we have also decisions that are super frequent. Let's put the example of a production line, to repair a line, to maintain a line, or to change a parameter of production. So at any scale, it matters, but it's essential to understand the frequency of our decisions. So if decision science, as we said, is the process of monetizing data, we are typically talking about data all the time, as the new energy or as the new oil. I prefer energy. But what is this data about? Is actually, it should be an enabler for taking better decisions. It's just through our decisions how we change the world. So data, it's nice to have. Good data is better to have, and good decisions at the end are really impacting the performance. So an approach that is just purely mathematical could be heuristically correct, but the issue is about the acceptance of these decisions. So we try to not be naive here, basically trying to understand how we can change behavior. So the facts here is about putting in combination these different disciplines here, data science and social science, and of course managerial science, into a unified field to help this decision making. So that's basically our approach. Now, you have seen, of course, more than 13 years ago, Davenport segmenting analytics. I think it's quite spot on. I think it's quite useful. It makes sense. It's rational. You want to start descriptive, and then you would like to get into prescriptive agenda. That's the typical sequence. But I also like to be talking about understanding how we can change decision making, or how we can improve decision making. Typically, we have been, using data mining or analytics, if you wish, or BI to explore data, to look for inspiration, understanding, averages, or understanding variations. Now, these was not driven to a specific decision making. This was driven for more, an inspirational work, if you wish. Now, with a statistical inference, and typically you are focused on, how to make one decision, how to understand the probability of this decision, how is the, the distribution of, for example, a KPI. So you are basically using statistics to take important decisions. Now, with the development of machine learning and AI, we can, automatize this kind of, exercise of building recipes. But it's it's still relevant to actually use statistics to validate how this machine learning algorithm is impacting and what is the details of this machine learning algorithm, especially if you need to understand the root cause of decision making. So the kitchen analogy, I think this is very well used, but I think it's a very simple way to explain, our users how we work. We are typically working in this process. We want to deliver a better decision making. The decision, it's about the final dish. It could be around a pizza. If you want to do a specific pizza, let's put a pepperoni pizza, but you need to know what is this type of pizza that you want to make. So it's completely different if you want to do a pricing optimization model in a context with, a lot of competition compared to if you want to do, safety stock optimization in B2B. So you need to really understand what is the dish, basically. And that has to happen before starting the process of analytics. So really working with the business users or business owners to understand decision making and what is the current context. Now, if this decision challenge is clear, defined, then you enter into the data, and then you can understand if you have good ingredients. So your data is actually with enough quality to cook something. Then you go and basically use some kind of appliances. And now we have good appliances. We can basically use machine learning, deep learning, but also we can use classical methods. And then we understand if we can build a recipe to make a good pizza, basically. So this process is super straightforward, basically, but it's starting, as I said, with the business question. Now, what we have done in Tetra Pak is basically standardizing the data science into 3 steps, basically. So we have first step, which is the proof of value, and this is an iterative approach, which is typically using CRISP DM as a foundation. So the details of the process of the proof of values is based on CRISP DM. We start with a total opportunity. This is the a prioristic impact of the algorithm. We could typically simplify and talk about cost reduction, annualize it, or we can talk about net present value, annualize it. Then we try to understand the baseline, which will be, of course, used for calculating the value added, which is what we call it empirical value. Now, if we prove the algorithm could improve decision making significantly, we end up with an empirical value in our pocket, and that will put the pressure on resources for deployment. But also it will put the pressure of what is the user interface for improving decision making. If this is something new or if this is just integrating the algorithm in a current decision support system, for example. And then finally, the step 3 is actually ensuring the service, ensuring the performance of the algorithms, ensuring that the users are actually changing or improving behavior based on this algorithm. So we need to really understand how the eventually this pill that is the algorithm is impacting decision making, and that's what we call a continuous value. We are translating the effect as we go. From this clinical trial to this scaled application of the algorithm, and this financial controller is actually a very important part of this exercise, because we are trying to put accountability early on in this process. So this process is about creating value for the company. It's not for fun. It's basically to make business bigger and to minimize risk. So we put financial control in early on in the process. That's a little bit it. We have a collaboration process. So this is not just data scientists. We have a set of roles and responsibilities. So each of these, let's say, main counterparts in the process are basically, the business analysts, typically are the business owners. So they are placed in the business, understanding the current performance, current decision challenge. And they should point us about the pains, and they should point us about where, how we are operating now with, what type of decisions we are taking and how good or bad are they. So descriptive analytics is key to start with in this journey, but it's typically should provided by the business analyst. And then we are basically providing with a team of data scientists. So there is a kind of, a challenging exercise here where business is putting the pain and is putting the current context, and we are trying to start thinking about how we could improve decision making through algorithmics. Now, we typically are the model owners here in this process, so we would like to make sure that these models will be deployed efficiently, and then they will be having the same accuracy as in the proof of value or after the proof of value, but in production. We have also built, a collaboration process with, in this case, the data engineers, global IM in our case. So they are typically starting with us in the journey, in the first proof of value step, getting the right data quality and performing this what we call cold data ingestions. But after that, as Jan was talking, deployment exercise is typically the challenge, because you need really to get this model up and running and in scale. So you need to have continuity, you need to have quality. So this is about reliability, which is completely different from the proof of value, which is about research and innovation. Here you want to be scalable. We have for that a different set of roles, which is it's taking more relevance, the DevOps compared to the data scientists. And we are putting this structure now of deployment and methods to be scalable early on. The last part, but not least, this is actually our final stage, and it is actually our main day-to-day business, is to serve models. So really working by exception, understanding in which situations the algorithms are working, or where the algorithms are basically they have stopped predicting because human behavior changed through the algorithms. So that's actually ensuring that we could decommission these models, and we can try to retrain new models based on the new context. And that's what we do for living typically in the center of excellence. So serving the algorithms and improving the value of these algorithms all the time. So at a certain time, we say, okay, maybe we need to run a new POV actually to tackle the same problem that we were doing before. So I will not enter here because this is the details of the proof of value. This is a widely methodology, as I said, CRISP-DM. It gives us a structure, traceability, and reproducibility of what we do. So it makes us understanding what we try and what we learn. So I think it's extremely useful, and we are using it. Now, what I want to show is basically, how we feed the pipeline. We feed our pipeline based on, of course, our typical business process for Tetra Pak, and our 2030 strategy, which is pointing to, key elements here. And so we have typically a challenge, which is, it's a bottleneck. It's a portfolio optimization challenge. You want to tackle the problems that they have more impact to the organization, and they can be delivered in less time. So how we do that, how we prioritize this portfolio. In a nutshell, we have an equation which is basically, we have the total opportunity, as I said, that is the a prioristic impact of the algorithm in millions euros per year. and we have a probability. This probability is about what we call a success probability, but it's a combination of things. It's about complexity of the problem, for example, number of features, number of hypotheses, or it could be around what is the current context of data quality. Do we have frequent data? Is this just survey data with not very frequent information? So we try to make a score based on our data scientists and based on the data experts. So both of them are part of this scoring. And then, of course, we need to understand how long it will take to get the actionable insights. So this is the lead time. So the part of this equation, it's about number of days, number of weeks, actually, to get this value. It's not about money in this case, but it's about time. So we try to maximize this time to value function in our portfolio. So we have itself that the Center of Excellence has a portfolio optimization, if you wish, proof of value itself. So how we can maximize this equation? I mean, there are some recipes. First, try to not reinvent the wheel. Try to start with simple and known problems early on. So, and connect with your P&L. So we are typically connecting, for example, if we talk about sales lead optimization, we are talking about the specific KPIs that are well known, and they are, widely used models, for example, like classifiers, customer lifetime values, etc. But they are really connected to, to growth. We are not in this case too far from that. We start with some, already recipes developed out there. And we are also trying to classify our POVs in a way that we understand what is the decision-making target and what was the type of model. So at the end, we have a way to not to have economies of scale and reuse algorithms into different departments. So also how we can maximize the success probabilities by simplifying these problems, trying to tackle problems that are actionable, for example, that are using attributes or features that are actionable by Tetra Pak. I would put the price is an actionable variable compared to the weather or compared to competition. So you want to start with something that you can take actions. And of course, you want to start with something big in million euros. But at the same time, when you talk about the problems, the POVs, you would like to start with low complexity first, and then try to also focus on what are the contexts with big data quality, really frequent data with low bias. So with that said, these are simple recipes, but it's about starting simple and prioritize. But also it's about the lead time. We are trying to control the efficiency of the process, as I said, the crisp the end process, but also the entire process. So we have some recipes about where are the bottlenecks when we are collaborating. Vast majority of the bottlenecks has to do with human collaboration, of course, and less about the data and technology. But we would like basically typically to be efficient. So we want to minimize this lead time because if we can minimize the lead time, we can tackle more problems and we are increasing the value of portfolio. Some lessons learned about, some values that we have created and we have increased significantly the accountability for this empirical value. Just to remember, empirical value is basically is the added millions of euros that we have been able to prove with these algorithms compared to the previous situation. So we have some lessons learned about that, and we are basically in some of these projects we have already deployed the algorithms, and some of them we are actually serving as a service. So again, accountability is key to get this done and also to get this prioritized. So that's why we are trying to connect this with the business transformation office, because each project is a business transformation project. It means that it will change the process of decision making. It will require people to act differently. So it's not just putting technology out there. With that said, I would like just to talk about two examples as a reference. So we have some cases, but I will try to focus on two of them. The first one is actually a value-added service that we have built, and the second one is an internal value or internal cost reduction, which is the safety stock optimization. So I will start with the last, the base mat. This is very classic POV. We basically try to minimize the safety stock for our made-to-stock part of the supply chain, which is our base and add material part. We are typically, the challenge here is to manage a demand which is coming from another business. So we are B2B, so we have huge volatility. And this volatility is impacting the forecast accuracy. So the issue here is that we need to, procure, we need to reorder material to suppliers. And with this huge uncertainty, we need to good methods for forecasting, basically. So what we have done is, we try to understand what was the previous situation. The previous situation was that, the business was using SAP APO. They have a process, they have some standard ARIMA methods, but these are of course not, or they are sub-optimized and they are not fitted for the type of demand that Tetra Pak has. So what we have done basically is we have used the last methods in terms of machine learning for trying to improve the time series forecast accuracy. And basically we have been analyzing different methods and different steps towards putting these methods actually in production. So what you have actually in your right, this has been different steps towards a reduction of safety stock that we have tackled with the business. The first one was basically to use a simple forecasting improvement compared to the current situation, and trying to understand, which method was actually, significantly better compared to the APO. The second step was actually trying to fine-tune the algorithm to the specific lead times of the supplier. So really understanding the, coefficient of variation of forecast errors, but within the lead time, specifically for each, SKU combination. That was the 2B2. And then we actually try to use the latest techniques of machine learning in this 2B3, trying to tackle especially the high volatility SKUs. And then the final stage is actually trying to improve the demand. So we have tried to improve the demand sources, actually trying to use more unconstrained demand sources. And by unconstrained demand sources, I mean, we are typically censoring demand from customers. We are putting processes and humans in this kind of exercise of planning. So we have tried to use, the more, let's say, original source of demand coming from customers, really connecting with them. And that has been actually a, big impact, of course, because we can reduce this bias. So that has been basically an impact around 34%. Nowadays, we have implemented this 2B2. So with this 35% now implemented, we are basically, we have a clear roadmap towards the next steps. But this has been one of our first POVs. I will talk about another one, which is basically a forecast. It's a service, which is it's an external value for our customers. We have a processing industry, which is focused in trying to deliver, in this case, a production line of cheese. In this case, it's cheddar. So the whole challenge of producing cheese in this case is about controlling the variation of moisture and fat together with the pH. So we have typically the problem of variation. So variation of moisture affects the quality, affects basically decreasing the prices and decreasing the productivity. So what if we can use a machine learning algorithm that we could somehow, we could deliver basically the optimal parameters of production continuously based on the different batches of milk that we have, that the customer has. We could somehow give different recipes of recommendations per batch, and minimizing variation and maximizing, in this case, moisture. So that's exactly what we developed. We have been able to reduce 60% variability in these production lines, and we have been able to actually prescribe decisions also to increase the moisture to of course within the ranges which is connected to the specific products. So that's basically it, and that's a value-added service for us. With that said, that was actually my presentation. I will just pause here.
Thank you very much, Alberto. That was awesome. Very interesting to get Tetra Pak's perspective on this. We're not super many people in this meeting, around 34. So I was hoping to open the floor for people to ask any questions that they may have for Alberto. Anyone else? Anyone who has any questions? If not, I have some questions. So you were talking about the deployment stage, Alberto, in your presentation. I was trying to understand what are the specific concerns that you're experiencing at Tetra Pak, and how do you address those? Because I think that many of the software center companies are in the same stage as you are, that the transition from a successful prototype to deployment in industry is actually, or at the customer, for instance, is actually surprisingly difficult in many cases.
Yeah, I think you mentioned vast majority of the challenges. What I can say is that, typically, and I agree with you that, this data science project has been thought like, you have to, start with a research project. You start very small, and then eventually you scale. But, it's extremely important that really upfront we understand how will be the final product to be delivered, right, and to be actually executable. And right, that this is a mindset that we need to push forward really early on, especially right, in situations where you have, to scale algorithms using, interfaces or using previous decision support system. So it really requires an exercise of thinking about how to use the algorithm, in the final stage. And this requires basically to have people, exploring this kind of, maybe design thinking approach really early on. Right. We are doing this exercise, but, it's extremely difficult for business users to think about that. And it's, it's really about pushing them with the right tools, the right examples. I think it's important to, simplify at the end recommendations. So what is the prescription that we are aiming with the algorithm? Right. We are not trying to put reports out there. We try to put decisions out there, or even automatizing decision making. Right. So that's our work. That's what we do. That's why the business transformation office is part of, or we are part of that, because we really think that it's about, changing human behavior, and that is not just about data and, quantitative methods, but it's really about process. It's really about understanding bias today, that and how humans are operating in this decision making. Right. So, yeah.
That's a great point. With some of the companies that we're working with, for instance, at Microsoft, there is a continuous delivery of new machine learning and deep learning models in production as well. which would mean that I do not just have a project that at some point ends and then is quote unquote done, but I'm looking for ways in which I can have continuous value delivery and continuous improvement of what we're doing. Is this something that you've been looking at, and how do you look at that at Tetra Pak?
Exactly. I mean, the final, as I said, this is a never-ending kind of situation. We are putting out there models that they are like products. So we are basically controlling them along the time. We need to really understand how they change, how they impact, process, how they impact the business. So for us, this is the typical situation of, changing the company from, controlling products, developing products to developing models. Right. So it's really about changing this mindset, treating model like products with the same level of respect, let's put it that way, and really controlling along the time. It requires coordination, it requires prioritization, but it requires, of course, accountability. This has been, as I said before, is one of the key lessons learned. You need to have accountability of how the algorithms are impacting your business. If not, this can be ending in the situation with this small house that you had in your slide.
Exactly. We have a question from Alex Rukov. Alex, you are muted, so feel free to ask your question.
Yes, hello. Thank you, Alberto. Thank you, Jan. A very, very good presentation. I have a short question about the expected lead time. You went through it fast. You explained that, there's a variation for all events from starting from business understanding until the service. Can you elaborate more about that? I mean, you need to go from each step to others to start the other step. There's no chance of starting in parallel some of the steps, right? If I understood you correctly. So
correct.
So if you look at the variation or about, I'm more interested in the modeling and insight. If you can go to that slide, was one of the slides.
This one, I guess.
Yes, exactly. So can you please just spend a couple of minutes and explain a little bit more these steps? It's really interesting, if it's possible.
Exactly. I mean, you have spot on. You mentioned, I mean, this is a waterfall at the end. Even that we are iterating and we are doing agile, at the end you have some kind of steps, and it's important to do these steps towards minimizing risk. You don't want to go from business understanding really straight on the modeling and insights if you don't have to actually check your data quality, right? So what we have done is to really understand the average, of course, of these lead times, but also understand the variation of these lead times in each of these projects, and really trying to explore the root causes of that. So at the moment, I mean, I'm just showing here some distributions, and each of them are really projects that we have done. But for me, it has been really important to do this exercise as director of decision science, really to understand which were the business units that were actually really working more lean, which were for example, the data sources that we were able to really use more quickly. So really, trying to understand the root causes of these lead time variations. And that is an exercise that we are, of course, continuously doing, and we are trying to continuously improve based on these insights. So you need to have this traceability. You need to connect each of these POVs, of course, that they are in the scripts into this deployment, because at the end for us has been also important that, when we are building this collaboration with, data engineers and DevOps with Global IM, at the end, we are part of serving the same value. So we have connected this process, and of course, efficiency is big part of the story. Also to manage expectations of main stakeholders. We need to really get, this good accuracy also from our side. If we start a POV, we need to know early on what it's going to be in terms of time.
Yes, thank you. Because just from the perspective that the management stakeholders, need to analyze this information quite in details, because I come from an R&D Volvo Cars, and there was a presentation showing that we are also working agile and scale agile. So we have some processes that we move from waterfall to agile, and this is really interesting in our case to understand what development loops been taken over from waterfall to agile, and we have coped with some difficulties, and how the distribution of our risk were. That's really interesting, Roberto, for me to know. Thank you.
Excellent. So before I wrap up the session, Alberto, final question: is your team already making enough money for Tetra Pak to fund yourself?
Yeah, I mean, the short answer is that we are. I think we will say we are quite profitable, if you put it that way. For us, it was, as I said before, the first case, the safety stock optimization case.
Right.
With that, we have been able to get a payoff of probably 10 times our team with just the first 2B1. So I mean, again, it's extremely important, this element of self-sustainability. Yeah. So we are not a cost center. We cannot be a cost center, because if AI is going to change the world, we want to change business models.
Exactly.
So we cannot be the next technology. It's just a new concept of business models.
Excellent. Good.